Hey everyone, welcome back. I'm actually recording this before spring break, so hopefully things haven't gotten too crazy. Today we're going to talk about something called mole ratios. And it's going to involve a little bit of the conversion factor stuff that we've done in the past. These conversion factors are really easy, so even if you're not a huge fan of conversion factors, I think you're going to be just fine today. This is going to be kind of a two-part section. So we're going to do half of it today, and then we'll do some more stuff tomorrow. And remember, if this kind of thing is difficult for you with conversion factors, I'm available for video conferencing every day, a different time, A days and B days, but you can find those times on Canvas. So I really want to help you out as much as I can. We're going to start by writing out a chemical equation, very simple one. It's going to be hydrogen and oxygen reacting to form water. And we're going to talk for just a second about what this equation actually means. So this is telling us that if I have two molecules of hydrogen gas and one molecule of oxygen, they make two molecules of water. Even though there's nothing written in front of the O2, we know its coefficient is actually a 1. We just don't write that. So if it helps you to write in that 1, that can be good. So I just talked about molecules. I said 2 molecules of H2, 1 molecule of O2. The thing is, in chemistry, we never work with single individual molecules because they are too small to handle. You can't go and just pick up one molecule. That's just too small. It's impossible to do. So what we work with are bigger groups of molecules. And you might remember the way that we count groups of molecules is we count them using something called the mole. So you might remember that the mole is a number, and if I have a mole of, say, hydrogen molecules, that means I have 6.02 times 10 to the 23rd hydrogen molecules. You don't need to remember that number for today specifically, but you just do need to understand the concept of a mole. Now what's nice is that these coefficients, I can use them to talk about moles just the way I talked about molecules. So I can say if I have 2 moles of hydrogen molecules and I react them with 1 mole of oxygen molecules, I can make 2 moles of water molecules. Okay, and 2 moles of water molecules is like 2 tablespoons of water, just to kind of make that a little more concrete. So I'm going to show you what types of problems you're going to need to be solving in this section. So sorry we have to write these out again, but they shouldn't be too long. We're just going to do 2. This first one is going to use this reaction up here, and it is how many moles of O2 would be needed to completely react with 5.2 moles of H2. Okay, so we want to look at this just like any other problem with conversion factors. So we want to look at what the problem is asking for. So it's asking for moles of O2 and what they're giving us. They're giving us 5.2 moles of H2. So at this point, you guys should be pretty comfortable with that we always put our given at the top here on our conversion factor table. Now, the conversion factor we're going to use here is going to be new, but it's very, very easy. All you need to do is look at what unit you're starting with. So right now I'm starting with moles of H2. It's really important that you don't just write moles, you need to write moles of H2. Because every single unit here is going to be moles. It's just going to be the molecules are going to be different. So we're starting with moles of H2. We want to cross out moles of H2. And we can use this reaction up here as kind of a recipe to give us the conversion factors. So this recipe, if you will, tells us that for every 2 moles of H2, I need 1 mole of O2. Okay, so the conversion factor that I'm going to use for H2 is going to be 2 just from the coefficient. So every single time in these problems, you're going to be looking at the coefficients to make a conversion factor. So for every 2 moles of H2, I can cross out moles of H2. Now I'm trying to find moles of O2. So I need to look for the coefficient of O2. It's up here, it's a 1. So we're going to have 1 mole of O2 up here. And that's it. These problems are all just going to have one conversion factor, and all of the units are going to be moles. The only difference is going to be which molecule. So to solve this, I'm just going to multiply across the top, 5.2 moles of O2. Multiply across the bottom, the only thing left there is a 2. And if I divide those, I'm going to get 2.6 moles of O2. Okay, so the key things here are use your coefficients to make a conversion factor. Again, remember, conversion factors are ratios. So this is the ratio of how many oxygens I need for the number of hydrogens that I need, whether it's molecules or moles. Okay, let's just do one more problem. This problem is going to have a different reaction, so I'm going to write it in a different color. We're going to do C2H4 plus 3O2. This is going to be a combustion reaction. Produces 2CO2 plus 2H2O. And our question is going to be, if I have 5.7 moles of O2, how many moles of CO2 will be produced if all of the O2 reacts? Okay, so there's a lot of words here, but let's just pick out what we're trying to find. So we are trying to find moles of CO2, and they're giving us moles of O2. So let's look at our equation and see where these molecules are. Here's CO2, so this is what we're looking for, and here's O2. Okay, so let's start with what we're given. So 5.7 moles of O2. And I know that for every 3 moles of O2, I will make 2 moles of CO2. Alright, so you'll notice on this problem that we did earlier, I went from one reactant to another reactant. Here I'm going from a reactant to a product. That's totally fine. You can go from any molecule to any other molecule in the equation. So I want to cross out moles of O2, so let's use the coefficient of O2 down here. 3 moles of O2. And let's use the coefficient of CO2 up here, since that's what I'm trying to find. So 2 moles of CO2. And then moles of O2 crossed out. I'm going to multiply across the top. That'll give me 11.4 moles of CO2 over 3. And that will give me 3.8 moles of CO2. Alright, so that's all you need to do for your assignment. You're just making ratios out of the coefficients of each, or of whatever molecules you need to, and making things cancel. Alright, so if this is tricky for you, again, come to my video conferencing office hours, and I really am happy to help you out. I think you guys can all do this. It's very doable. Just let me know if you have any questions. Have a great week.